Hello there. In this video, or it will probably be a series of videos, we'll go through how we are going to wire up our lighting control module, which is this gizmo here. It's something that me and my brother have been working on for about 6 months now, and we've changed how it functions quite a lot from the start, and we built quite a lot more functionality into it. So I thought it might be useful if we go through the whole process of deciding what the lighting control module can do and how to put it all together. And then once you've done that, you then need to program the thing to get it to do what you want it to do. So I've started off, this is a rig I made up quite early on to just test various things out. And it's been sort of superseded by what we eventually came up with, so it's sort of just been pulled to pieces at the moment, as you can see. So I'm going to use this as my new layout, sort of test rig as it were. And to start with, I thought it would be useful if I try and think about what I can use the pins for on the lighting control module and what they can do. And if you can see on here, you can see that I've numbered the pins along the little terminal blocks here, both sides, so I know which pin is which. So I'll refer in the description of this video, I'll put a link into our Facebook page, which includes our user manuals and various other bits of information. But if you're completely new to the lighting control module, I'll go through the sort of start to finish functions really. So basically, when we started this project off, we had quite a simple system of setting lights to do various functions. Quite quickly, we realized that that was a bit limiting as to what we wanted it to do. And we developed that even further. And that process has been going on steadily for about 6 months or so. So what we've actually ended up with is there are 16 channels on the module which this runs off, which is an ESP32. And that allow us to do various clever things such as dim light and flicker things and various other clever things. And those 16 channels, that's the maximum number of channels you can have with an ESP32 microcontroller. So there are 16 channels which we can do clever things with. Now I'll explain a bit more about why we found that quite limiting. So what I'm going to do is, out of our 16 available channels, I'm going to assign various tasks I want them to do based on what I already had in place in my little rig here, so I don't have to sort of reinvent the wheel, as it were. So let's have a look at that very quickly, and we'll go into later on, we'll go into what available functions we can use any of those channels for. So let's start off with our wish list, and as you can see, even though we have 16 channels, I've filled that up very quickly. And part of the reason why we ended up changing our system is because we quite quickly realized that 16 channels, even though it sounds quite a lot, it didn't give us much capability to do more things with it. So and I'll explain how we got around that limitation in a bit. But let's quickly go through what our wish list is on this part of the system, the 16 channels we have. Now the 16 channels, we found that is best suited to just ordinary LED lighting, and I'm sure you know what an LED is, one of those. And the reason why we said that was a good thing to do was because it meant the LEDs are small enough to put into things like traffic lights and on the tops of police cars, and welding effects, those sorts of things. So let's have a look what we came up with. So we have 2 traffic lights on our system. There's 1 and there's 2. And obviously each traffic light needs 3 colours. So we have traffic light 1 red, traffic light 1 amber, traffic light 1 green, traffic light 2 red, traffic light 2 amber, and traffic light 2 green. In addition to that, we've assigned 2 of the channels to a Belisha Beacon 1 and 2. And so you can see it's very easy to fill up how many channels we've got. We've got 2 traffic lights and we've got some Belisha beacons. Okay, we move on. What else have we got? We've got street lights, and we've actually got 3 street lights on this little rig here. There's 1, 2, 3. So 3 street lights, but we're using the same channel for those 3 lights, so they will always work in tandem, connected together. You can't have different lights doing different functions. We got our next channel, number 10. We've got a police car blue flashing light, which is here. We've assigned that to that one. We've got number 11, which is our welding effect, which we've put inside the little garage here. These 2 channels here, pin numbers 21 and 22, we've kept those back for the moment. The reason for that being is that they do a special function. We can use those to do anything we like, light up anything, traffic lights, whatever we want to do, but they also have another function, which is to power a little OLED screen, a little display screen, which we'll go into later. So we're going to keep those free for the moment, because once we've assigned them to do a task, if we want to add an OLED screen in the future, we would then have to remove that and assign it to something else. So just for the sake of ease, we've kept those free. The last 3 channels we have assigned to a fire effect, and the reason why we got 3 channels is because our system has 3 different functions: a glow, a sort of amber, and a sort of flickering flame, and we'll go into that in more detail. So we've got 3 separate channels for that, even though those 3 effects will be in one cluster, as it were. So yeah, as you can see, we've quite quickly filled up our channels already. Some of those channels are already in place on here, so we don't need to add those in now, but there are a few that we will add in, which we'll do later. Now, you might have noticed there's something missing from that list there, and that is there are no buildings. And when we started this project off, we said, well, the primary thing you're going to want some quite clever timing for your LEDs is to light up buildings when they come on, when they go off, and what functions they do. So what we found out is that even with all these functions here, and let's have a look here, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9 buildings there. So if you wanted all those to be independent of each other, that's 9 of your channels used up. So you can see we're starting to run into problems with how many channels we've got. And the way we got around that problem was we quite quickly realized that there had to be another option on the table. So what we ended up doing was we reconfigured the system so that we have an additional 3 channels which are used for addressable LEDs, and they don't do anything else other than that. And that gives us the potential to have control over hundreds of LEDs. And if you don't know what an addressable LED is, here's some here, and you may have seen these before. They're little LEDs that are on a strip. But what you might not have seen before is these LEDs have 3 connections. You have a power and a ground as per normal, but they also contain a little data channel, that link in the middle there. And not only that, the addressable LED itself is like a sort of LED like this, but smarter. It's got a brain in it, and that's what enables us to tell that particular LED what to do. In addition to that, it also has 3 colors inside this LED, so we can more or less make that LED any color we like in the spectrum. But in order to use LEDs, they have to be linked together like a daisy chain. So that's not going to be very convenient, for argument's sake, for an external street light, because it's quite bulky and it has to have all these 3 connections together. But what it is good for is it's perfect if we want to light up these 9 buildings. Because all we need to do is put these little LEDs inside the building somewhere, and it doesn't matter if we do it on a room basis or on a floor basis, but what we have to make sure is that they are all still connected together, otherwise we won't be able to control each LED. So what I'm going to do now is I am going to look at my LED availability, and I'm going to apportion where I want my LEDs in this scenario. So I will do that now, and that'll take me a bit of time to work out, but it's vitally important that we work this out right at the start, because it means we know how to configure them later on. So let me do that now, and we'll come back to that and you'll see what I've done. Okay, I've come up with some ideas for my addressable LEDs. Just out of interest, I've also decided I might change this around a bit because we have a lightning effect as well, which can take 2 channels up. So I haven't quite decided whether I do the fire or the lightning on those yet. But let's have a look at my my addressable LEDs now. I'm using we've got 3 channels to use, and I can't quite remember how many we said, but it was a lot. I think we had 300 LEDs per channel, so we got absolutely hundreds of them. So I'm using channel 27. If I wanted to, I could split these up over the 3 channels if I felt that way, but we don't need to worry about that. So channel 27, and with addressable LEDs, you always start at 0. So that would be LED 0. So on the roll that I just had lined out, the very first LED from the lighting control unit would be LED 0, and the next one 1, then 2, then 3, whatever. So what I've done is I've just fleshed out how I think this will work in practice. Buildings like the pub, I guess it would be nice to have a separate light for upstairs and a separate light for downstairs. The bank, the hotel, I've split that up into an attic level, the 1st and 2nd floors, and actually I forgot that, so I put it over there instead. The hotel ground floor. The newsagents is there, so we've got a 1st floor and a ground floor. The house next door, I've got upstairs and downstairs. The next is a sweet shop, then a police station, then the garage, and then the florist. So in total we have 14 LEDs because we always start at 0. So what I need to do is I need to wire up the LEDs on the back of my layout so that 0 is in the upstairs pub, the next LED is in the downstairs, and I obviously need to make sure that they are all nicely daisy chained together. I mean, by the time I finish this, it will look a right mess because I'm not exactly neat when it comes to doing my wiring. So what I'm going to do now is the fun part, and I'm now going to wire up my little display here so that it confirms all my connections for my 16 normal LED channels plus my other 14 adjustable LED positions. So I'm now going to go in and do that bit of fun. See you later. It's just occurred to me while I'm building and wiring up this layout here, we need to cover something. We might as well do it now because it's a convenient point to do it, and that is the wiring of your traffic lights, and if you've got the signal module, your signals. The reason why we need to cover that in detail, and we go into quite a bit of detail in the user manual, is because there are 2 versions of lights that you purchase. Now this one here I've made myself, so I know which way it is wired up, but you will basically get, in any one you buy, a cable, a little wire for each of the lamps. So in this one here I've got a yellow, a red and a green, and I've also got this other one which is normally white or black. That's the common. Now unfortunately there are 2 types, and if you can't tell just by looking at your signal or traffic light which one you've got. And the 2 types are this white wire or black wire, if it's black, is the negative common, but in some versions it's the positive common or anode common. Now we need to figure that out, and if you don't know what it is, if it doesn't tell you in the ones you've bought what it actually is, your traffic lights or signals will not work, because you won't, you may get lucky and they will work, but basically you won't know which way to wire them up. And the difference is that the common, this one here, either goes to the ground on a common cathode signal or traffic light, or to the power on a common anode signal or traffic light. Now I know which way I've wired these up because I've made them from scratch. But let's say I think that this is a common anode, and I put the positive supply on this, and the 3 cables go back to the lighting control module. Let me do that. So I put the positive on the white, and I'm going to put the negative on the green. nothing. So nothing's lighting up. That strongly tells me that this isn't a common anode, this is a common cathode. So let me switch those cables round. So now I've got the ground or negative on the white wire, and I'm going to put the positive on the amber yellow wire. Oh, there we go. So I know for certain that these are common cathode traffic lights. I know that because I made them, but this is how you determine which one you have, and you have to work it out so that you know how to wire them up properly and also how to set them up in the lighting control module. So just to recap, I've got the ground on the common cathode wire, which is white in this, and if I put my power voltage on any of the other 3 coloured cables, that will light up that particular one. So that's just to show you how you can determine which one you have, and I'm using a little power supply at 2.5 volts because obviously I don't want to destroy my LEDs. Anyway, I thought that'd be useful to do that now because I've got it right in front of me. Right, I've wired up the LEDs on my layout now. I've tried to reuse as much as I can from the previous layout, which is why it looks a bit of a mess. But if you can see now, I've got various wires coming from my LEDs. That one there is the welding effect on the car. That one there is the police car blue light. And I've got 3 here which are coming from one of my traffic lights. So what I've decided, and all these will go back to the pins on the lighting control module. But what I wanted to show you is a couple of things. Firstly, I've been collecting the grounds from the LEDs and collecting them together. So by the time that I get back to the lighting control module, which is here, I've only got to put a single ground in the lighting control module. So that's good because that saves quite a bit of wiring on the lighting control module. The other thing I did want to show you is I mentioned about street lights. I've got 3 street lights on the front, and the pins on the lighting control module, you don't really want to put more than 2 LEDs on it because that will then start to overload it. And there are various ways we can get around that, and this is the most simplest way, is that rather than your pin on the lighting control module providing the power to the LEDs, the lighting control module pin switches a transistor, which is that little black thing there. So the connection back to the lighting control module is this little cable here, and that actually activates the transistor, and the actual power to the lights is provided directly from the expansion board. So there's no big power surge going through the lighting control module, it's just purely acting as a switch. So that's done now. So now what I'm going to do is I'm going to start to wire up the addressable LEDs which fit in the back of the buildings. So I'm going to do that now. Right, I've made a start on wiring up the addressable LEDs, and what I've just done is I've done a back for my buildings, and I've stuck on the addressable LEDs, and because they're going to be spaced out quite irregularly, I cut them up into the single LEDs. You just cut them along the line of the join, and then you can solder them all together. So what I wanted to show you here is all I've done so far is I've actually soldered the data line together. So the data line comes in here, and this is LED number 0. And the reason I've numbered them all is because it makes it very easy for me to know what sequence I need to solder them all together. So as long as your data line comes in and goes out, comes in, goes out, comes in, go out, you have no trouble at all. So if you can see there, it says DIN, which is data in, and DO, which is data out. So as long as you follow that sequence, and all I've done there is a nice sort of snaking line of data cable all the way to the end. Once you get to the end, there's no need to carry on, it just stops there. So I've got 17 LEDs here, 16 being the last one and 0 being the first one. So I'm happy with that. So all I've got to do now is wiring the the ground and the power supplies. And if you look there, you can see you've got the ground terminal at the top and the 5-volt terminal below. Now, you don't have to daisy chain them in order. They can be in any order you like. So you could have one power coming in here and feeding this end, and one power coming in the start and feeding that end if you wanted. But I'll probably do them in the same order that I've done the data cable, just to try and make it as neat as I possibly can. Okay, let's get on with that.